Hi, this is Gaurav. I am a software engineer at Guidewire. I am going to share an overview of the solution design that we proposed in OCM enhancement proposal number 105 to support running OCM on EKS natively. This proposal can be found in OCM's enhancement repository, and we will use this diagram to understand the sequence of events that are followed during registration using AWS IRSA. I've opened this diagram in my Miro application. It is the same diagram that we have added to the formal enhancement proposal. So the registration process begins by creating two prerequisite roles, one for both hub and spoke each. And as we can see in this diagram, the blue colored box signifies hub cluster and the pink color is spoke cluster. And all the arrows in this diagram are marked with numbers. And as we can see, arrow number 0 on both hub and spoke side is to assume the prerequisite role. And so it begins with both hub and spoke assuming a prerequisite role each. And these roles should follow a standard naming convention, and it should be created before the registration begins. That's why these arrows are marked with 0, because these are prerequisite roles and prerequisite steps. So the registration begins with clusterlet, or in fact, the registration agent in Spoke using Bootstrap kube config. And it will use the Bootstrap kube config to generate manage cluster custom resource on Hub, with the difference that this managed cluster will have two additional annotations. These annotations would be missing if this registration request was started using CSR-based authentication. And also note that in this diagram, in this flow, there is no CSR in the picture. So Spoke will only create a managed cluster resource on Hub. So once the registration request is created, the admin of the Hub cluster will accept the registration request by running clusteradm accept command, which in turn sets Hub accepts client property to true on managed cluster custom resource. The registration controller on Hub listens to this update, and from the annotations on managed cluster custom resource, it will decide that it is an AWS-based registration request. So it will first create a role and policy for this spoke on IAM, and then make an entry in AWS auth config map to map this newly created IAM role with Kubernetes group containing the name of this spoke. This is the mapping that allows IAM role permissions inside the hub for the spoke that sent this registration request. Even though in this diagram, we have shown AWS auth config map, however, for actual implementation, we are planning to use EKS access entries, which is another newer EKS's feature, using which an EKS cluster authorizes incoming requests. Creation of roles and policies is part of our enhancement, as this is very specific to EKS, and adding an entry in either AWS auth config map or EKS access entry is part of our enhancement as well. Next, Hub will create a namespace specifically for the spoke that sent this registration request, as well as it will create some RBAC resources on the Hub. It is shown using arrows number 7 and number 8. By the way, this is something that Hub does today for CSR-based authentication as well. Once the registration controller on the Hub is done processing this request, it will add Hub accepted managed cluster condition to this managed cluster custom resource to signal that it is done processing this registration request. A registration agent on Spoke is also listening to any changes done to this managed cluster custom resource. So on seeing Hub accepted managed cluster condition, it wakes up and it assumes the role created by Hub for this spoke. So this role was the one that Hub specifically created for spoke in the previous step. And using the prerequisite role that is assumed by the spoke, spoke will assume this role. This role on hub will have permissions to generate hub kube config specifically for this spoke. Next, clusterlet-agent or registration agent running on spoke will assume this role and it will generate EKS based hub kube config, as can be seen on arrow number 11, and it will save it to a secret called hub-kubeconfig-secret. At this point, the registration is completed from spoke side as well, and it adds a condition called manage cluster join on manage cluster CR in hub to signal that it has completed joining. Now that the registration is completed and hub and spoke have joined, admin of the hub cluster can create a ManifestWork in spoke specific namespace. And using this newly created hub-kubeconfig-secret, work agent running in the spoke will be able to pull this ManifestWork, and it will be able to create any resources in spoke. This is the end of overview of solution design.
Hello, everyone. My name is Suvaansh Kumar, and I'm a software engineer at Guidewire Software. So today we will be presenting you how you can join two AWS EKS clusters using AWS IRSA type of authentication. And you will be able to join using the manual steps that we have provided in our blog. So this will help you join two EKS clusters as OCM Hub and OCM Spoke or OCM Managed Cluster, however the way you want to speak about it. There are a couple of prerequisites before you start following the manual steps that are available in the blog. So one of the prerequisite is that you should make sure that the EKS API authentication mode is enabled for your EKS clusters so that you will be able to create access entries. And apart from that, you need to make sure before you run these manual steps, you are in the OCM repository, but in the solutions joining hub and spoke with AWS auth manually folder. My name is Suvaansh, but I will be representing the spoke admin persona in this presentation.
Hi, I'm Emily, a software engineer from Guidewire. Today, I will be representing the role of a hub administrator, collaborating with Suvaansh to complete the EKS cluster registration process with OCM. Let's dive right into the setup from the hub side. We'll start by setting up environment variables like cluster names, AWS account information for the upcoming steps. To uniquely identify the IAM roles used, we'll generate an MD5 hash, which incorporates information from both the hub and spoke clusters and serves as the suffix for the IAM role names.
Okay, and I'm gonna be doing the same thing in the spoke cluster side. Okay, and I'm gonna export these variables over here. And I will also export the MD5 hash. This will be used further to create our IAM roles and its respective policies. Okay, once I have exported these variables, I will go ahead and run the command to create the required roles and IAM policies on the spoke side. You will be able to find this command in our blog, and it also refers to some templates. That is the reason you are in AWS joining hub and spoke with AWS auth manually folder, so that you will be able to easily use the templates we have mentioned. So behind the scene, it is going and creating the AWS roles and policies in the AWS account.
Now we're back on the hub side. We'll initialize the EKS cluster as a hub cluster by running the clusteradm init command. Once the initialization completes, OCM generates a clusteradm join command which contains the hub cluster token and hub API server URL. Let me now share the information with Suvaansh to complete the registration on the spoke side.
Thank you, Emily. So once the clusteradm init command is run, I do have the token as well as hub API server. I will export it in my variables to be used by my other commands. So here I'm exporting them. Okay, now I will start the clusteradm joining command. While I will run it, I will tell you a little bit about this. I'm running the clusteradm join command. So while this is running, just letting you know about this new flag that is now being introduced to specify the registration auth as AWS IRSA. This is specifically for EKS based clusters so that you can complete the registration using AWS IRSA type of authentication. If you do not put any of the flag, by default, it will use the CSR based authentication. So this will take some time for the joining process to be completed. So now the joining process should be completed. So now I will go on to the further steps. So the next what we need to do is we need to scale down the clusterlet operator so that we can make some modifications on it. Okay, so now it is scaled down. So now we need to update the deployment clusterlet-agent so that we can volume mount the AWS CLI onto it so that it can complete the registration process using AWS CLI. Okay, so as you can see, the deployment is now patched and it has the required volume mounted on it.
Back on the hub side again, we'll now create the IAM role required in the hub cluster's AWS account, similar to what Suvaansh has done on the spoke side. Now, all of these commands and policy template files are available in the solutions directory within the OCM repository. With the IAM role now set up, we're ready to accept the registration request by running the clusteradm accept command. Notice that there is an error that says no CSR is approved yet for the spoke cluster, which is expected in our manual steps as the underlying registration process does not create a CSR when using AWS IRSA as the type of registration. Let's also inspect the Manage Cluster resource to ensure the spoke cluster's request has been accepted. As we can see here, the spoke cluster now shows as a managed cluster, and the hub accepted condition is set to true. We'll then go ahead and create an AWS access entry to allow the hub IAM role to access Kubernetes objects on the hub cluster by mapping it to an OCM Kubernetes group, which already has permissions set up. Last but not least, let's also get the kubeconfig of the hub cluster by running AWS EKS update kubeconfig. Before we can share it with the spoke admin to create a secret on the spoke side, we'll need to manually update the hub cluster names in the kubeconfig to match what OCM generated in the bootstrap kubeconfig. So here I've created a sample hub kubeconfig to demonstrate the two fields which need to be updated to the string hub: the name under cluster, and the cluster field under context. On the side, I've made the changes accordingly in the actual hub kubeconfig. Now let me copy it and share it with Suvaansh.
Okay, thank you, Emily. So now I have the hub kubeconfig. Let me just export this variable. Okay, and the rest of the commands to manipulate this. Okay. Okay, and since we need to create a secret, we're gonna generate the hub kubeconfig-secret YAML. Okay, so what we're trying to do over here is that we will be generating our own hub kubeconfig-secret, which is required by the clusterlet-agent to complete the registration process and also the rest of the processes to fetch the ManifestWorks and everything. I'm going to show you the already existing secrets over here. Okay, so right now you can see that there is a bootstrap hub kubeconfig and there is open cluster management image pull credential secret. So I will apply the new hub kubeconfig secret, which will help the clusterlet agent to do its task. Okay, so So it is created, kube-secret. Okay. Hope to see this secret. Okay, now everything should be up and running. Maybe Emily, you can try creating a ManifestWork for us.
Okay, I'll use clusteradm to create a ManifestWork for the spoke cluster, which takes a namespace manifest. Once the ManifestWork is applied, a namespace called sample spoke namespace should be created on the spoke side.
Okay, and I'm going to check on the spoke side if there is actually a namespace being created by the name already mentioned. Okay, so this proves that we are able to connect it using AWS IRSA type of authentication because we are able to see the ManifestWork that is created on the hub side, and we are able to see that in the spoke side. And with this, our demo is complete. Feel free to use our manual steps and let us know if there are any questions, concerns. Hopefully, soon we will be contributing all these changes natively via OCM codebase itself. So you will not need to go through all these manual steps, and you'll be able to use these registration auth of AWS IRSA natively through OCM itself.
Thanks for watching.